When you push down at an angle on an object, the vertical component of the applied force, Fay, pushes the surfaces together. This pushing action increases the force pushing the surfaces together, which will in turn increase the reaction force Rn. The relationship between the lifting force and Rn can be deducted using Newton's law of force and motion. For the shown object, since it is not moving in a vertical direction, then forces up equal forces down. The force up is the normal reaction force Rn. The forces down are the object's weight, W, and the vertical component of the applied force, Fay. So Rn will equal W plus Fay. So we can say if we push downward at an angle on an object, then the friction force Ff equals the horizontal component of the applied force, Fax, and the normal reaction force equals the weight plus the vertical component of the applied force, Fay. Example 5. A 100 kilogram mass sits on a horizontal surface. What is the normal reaction force if a downwards force of 100 newtons is applied at 20 degrees of an angle to the horizontal? So we have a 100 kilogram mass sitting on a horizontal surface with a downward force of 100 newtons at an angle of 20 degrees to the horizontal. And we want to know what the normal reaction force is. Step 1, find the weight. Weight equals mass times g. Weight equals 100 kilograms times 9.81 meters per second squared. The weight is 981 newtons. Step 2, finding the vertical component, Fay, of the applied force, Fa. Fay equals the sine of 20 times Fa. Fay equals 0.342 times 100 newtons. Fay equals 34.2 newtons. Step 3, finding the normal reaction force. Forces up equal forces down. Rn equals W plus Fay. Rn equals 981 newtons plus 34.2 newtons. Rn equals 1015.2 newtons. Our general friction formula states maximum friction force equals the coefficient of friction times the normal reaction force. But if our applied force is downwards at an angle, then the maximum friction force equals the horizontal component of the applied force, which is Fax, and the normal reaction force equals the weight times the vertical component of the applied force, which is Fay. So we can substitute for Ff and Rn, and our formula becomes Fax equals the coefficient of friction U times the sum of the weight of the object and the vertical component of the applied force. So when we push downwards at an angle to slide an object, then the maximum friction force equals the coefficient of friction times the normal reaction force, or the horizontal component of the applied force equals the coefficient of friction times the sum of the weight of the object and the vertical component of the applied force. Example 6. An applied force of 150 newtons starts to slide a box across a horizontal floor. The force is applied down at an angle of 25 degrees to the horizontal. If the coefficient of static friction is 0.25, what is the mass of the box? So we have our box sitting on a horizontal surface. Coefficient of static friction is 0.25. We have an applied force of 150 newtons at an angle of 25 degrees to the horizontal, and we want to know what is the mass of the box. Step 1, finding the horizontal and vertical components of the applied force. FAX equals the cosine of 25 degrees times 150 newtons. FAX works out to 135.9 newtons. FAY equals the sine of 25 degrees plus times FA. FAY works out to 63.4 newtons. Step 2, finding the maximum static friction force. Since the object is just starting to slide, we can say the maximum static friction force equals the horizontal component of the applied force. So the maximum static friction force equals 135.9 newtons. Step 3, finding Rn. Using our formula, general formula for static friction, we can say the coefficient of static friction equals the maximum static friction force divided by the normal reaction force. So we can transpose and we can find Rn, which is equal to the maximum static friction force divided by the coefficient of static friction. Rn equals 135.9 newtons divided by 0.25. Rn equals 543.6 newtons. Step 4, finding the weight. Forces up equal forces down. Rn equals W plus Fay. W equals Rn minus Fay. W equals 543.6 newtons minus 63.4 newtons. W equals 480.2 newtons. Step 5, finding the mass. The mass equals the weight divided by G. Mass equals 480.2 newtons divided by 9.81 meters per second squared. So the mass of the box works out to be 48.95 kilograms. To summarize, when pulling up or pushing down at an angle to slide an object, then the applied force can be broken into horizontal and vertical components that can be found by using the angle of inclination and trigonometry functions. When pulling up or pushing down at an angle to slide an object, then the horizontal component of the applied force equals the friction force. FAX equals FF. When you're pulling up, the normal reaction force will equal the weight of the object minus the vertical component of the applied force Fay. When you are pushing down, the normal reaction force equals the weight of the object plus the vertical component of the applied force. Using our general formula for friction, maximum friction force equals coefficient of friction times Rn. When pulling up, the maximum friction force equals the coefficient of friction and times Rn. That formula becomes the horizontal component of the applied force equals the coefficient of friction times W minus FAY. When pushing down, the maximum friction force equals the coefficient of friction times Rn. That formula can be substituted with Fax equals the coefficient of friction times the sum of the weight of the object, W, and the vertical component of the applied force, Fay. The above formulas work for both static and kinetic friction. It is just the values of the coefficients of friction and therefore the maximum friction force that'll change. So, for pulling up at an angle to start an object moving, Fax equals US times W minus Fay. For pulling up at an angle to keep an object moving at constant velocity, Fax equals UK times W minus Fay. For pushing down at an angle to start an object moving, Fax equals US times W plus Fay. For pushing down at an angle to keep an object moving at constant velocity, Fax equals UK times W plus Fay. Example 7. A mass of 325 kilograms is pulled along a horizontal surface at a constant velocity by an upward angle of 35 degrees. If the coefficient of kinetic friction is 0.27, what is the applied force? So we have a 325 kilogram mass sitting on a horizontal surface. The coefficient of kinetic friction is 0.27. The force is applied upwards at an angle of 35 degrees. And the mass is moved along the surface at a constant velocity. And we have to find the applied force, Fa. Step 1, finding the object's weight. Weight equals mass times g. Weight equals 325 kilograms times 9.81 meters per second squared. The weight equals 3,188.25 newtons. Step 2, finding the horizontal component of the applied force. The horizontal component of the applied force is the cosine of 35 degrees times the applied force Fa. Cosine of 35 degrees equals 0.819, so Fax equals 0.819 Fa. Find the vertical component of the applied force. The vertical component of the applied force equals the sine of 35 degrees times Fa. The sine of 35 degrees equals 0.574. So Fay equals 0.754 Fa. Step 4, finding the maximum kinetic friction force. Since the object is moving at constant velocity, we can say the maximum kinetic friction force equals the horizontal component of the applied force. So, maximum kinetic friction force equals Fax, which equals 0.819 Fa. Finding Rn. Forces up equal forces down. Rn plus Fay equals W. So Rn equals W minus Fay. So Rn equals the weight, 3188.25 newtons, minus the vertical component of the applied force, which is 0.574 FA. Step 6. Using the general friction formula, find the applied force. So we can say the maximum kinetic friction force equals the coefficient of kinetic friction times the normal reaction force. So substituting our numbers in here, we get the maximum kinetic friction force equals UK times Rn, which was W minus 0.574 FA. So maximum kinetic friction force 0.819 FA equals coefficient of kinetic friction 0.27 times the weight 3188.25 minus 0.574 FA. So multiplying these units together, we get 0.819 FA equals 860.83 newtons minus 0.155 FA. Taking the 0.155 FA to the other side and adding it, we get 0.974 FA equals 860.83 newtons. FA equals 883.8 newtons. So our applied force is 883.8 newtons.